So hi everybody. We're here to talk to you a little bit about going from panic to peace and making your Kubernetes controller observability suck a little bit less. And we're going to do this by way of a bit of a story. So we've got 4 chapters in this story for you today. We've got starting with a fairy tale of finding and fixing a problem. We're going to go on Sid's epic debugging journey in chapter 2. Then we're going to see Victor's grand Kubernetes expectations, and finally finish off with the observability onion. So, chapter 1, the fairy tale of finding and fixing a problem. So once upon a time, there was an ogre named Shrek. And Shrek lived happily alone in his swamp, until one day, that began like any other, Shrek heard a noise. What could that be, he wondered. He left his dinner to investigate and found someone in his house. No problem, he thought. He grabbed the intruder and threw them out. But when he stepped outside, there was absolute chaos. There was panic. His worst fears had come true. Fairy tale creatures were everywhere, ruining his peace. His home was overrun, and his old scary ogre routine wasn't working. Whatever had happened, fixing the problem would take more than just roaring at it. So, Shrek traveled to the city to ask Lord Farquaad for help. And after many misunderstandings and pointless battles, he learnt that to reclaim his swamp, he must rescue a princess from a distant tower. He journeyed through perilous lands, dodged dangers, and even survived a dragon, who, surprisingly, wasn't as fearsome as she looked. Burned, bruised, but still determined, he rescued the princess. On the way home, Shrek began to wonder if returning her to Farquaad wasn't the right thing to do. Maybe there was a better solution to his problems. But when he overheard a conversation that seemed to confirm his worst fears, he abandoned that hope and went back to the original plan. After handing the princess over, Shrek realized he'd made a terrible mistake. And so, with the help of his loyal friends, he fought back and rescued her once more, and brought her home. And together, they all lived happily ever after. So, what's the moral of Shrek? The moral of our story here? Firstly, Shrek found that things were good in his swamp until they weren't. He realized he might not actually be solving the problems that he needed to solve in finding the princess. And he went on so many misdirections and false starts that he found out that knowing to find and interpret information is crucial. Just like debugging Kubernetes controllers. So I'm Kat. I'm product manager at Syntasso. We build K8s, and I'm here with Derik.
I'm Derik. I'm a software engineer at Syntasso as well. And today we're going to talk about from panic to peace, making Kubernetes controllers observability suck less, which will include some lessons that we learned when building K8s, because K8s, at the end of the day, is a Kubernetes controller, and we learn a lot building it. So let's go to chapter 2.
And chapter 2 is Sid's epic debugging journey. And this is a story from November 2024, and I said earlier I'm a product manager, and one of my favorite parts of being a product manager is I get the inside scoop of customers' problems. I spend a lot of time talking to them, trying to figure out what their pains are, but also their solutions, and in particular, the solutions that they've built to using our product. And in November 2024, I was invited into one of these sessions. It was a community of practice event with one of our key customers, and they were demoing our product, and in particular, how they debug using it. And this is our man, Sid. He's one of our favorite users. I gave this talk in Edinburgh, and he lives in Edinburgh. Here he is on a walk for 19 kilometers when he was there. Insane dude, but he was in the audience and got quite excited when we showed this picture of him. And he uses the product all the time. He has a lot of opinions and really, really good feedback, and is really interested in it. So he was showing how you would debug using K8s. And he started with an error. So he created this test promise, and a promise, you don't need to know it in detail, it's just a CRD, and it had an error in it. So created the promise, all good to start with. Next. He was showing the 7 Kubernetes-related aliases he had set up specifically for this demo. And these were these long commands that he needed to actually find a problem that he was having to repeat all the time. And this is when a little bit of a red flag went off in my head of like, oh, this isn't going to be a nice experience. I'm going to be a little bit embarrassed by the end of this story. So next, he applies the promise CR, And we did not, at the time, provide any way of making this process very visible. So we'd set up a bunch of watches on the controller logs. And anyone who uses Kubernetes will know that these are not particularly pretty, and it had a screen like this, which was hard work already. So instead, Kubernetes goes and finds and copies a pod name. So let's get it at the container level, let's open up the pod and set a watch on that. And maybe it'll be a little bit easier to debug. However, the pod name changes. This isn't great, which means you can't actually check that pod for the same CR that you're applying every time. So added a label to the container so that you can get those pod logs more consistently. We're doing okay. Next, we want to show some events. What's happening over time? So we showed some Kubernetes events. And I had another moment of like, ooh, we need to add some stories to our backlog now, because there was nothing Kratik specific in here. So we weren't making his life any easier than having to use Kubernetes in the first place. So put a pin in that one. And we're only on the first half of this epic journey so far. Now we've got another side that he has to go through. We're about 15 minutes into just a debugging story now. So the way it works, we don't just spin up one pod, we spin up many pods, which means you had to list all of them and check every single pod for errors. And because those logs are changing, he then had to set up a watch and grep for errors in those logs so that he could see which of those pods were failing. And then had the watch on that command. We're about 4 different tabs in at this point, maybe 4 or 5, all at the same time that Sid is having to go through one by one to try and find the error for us. Next, he had added a wait to the container and it execed in so that he could do a little bit more like hands-on debugging and investigate a little further. And this sort of sounds reasonable, but then you're like, why am I having to do this to change something? We've got 10 steps here. And this was the most embarrassing one for me, because he showcased our troubleshooting guide, where we had written up, this is what you should do when trying to debug our product. And I was like, oh dear, okay, I need to get my act together as product manager here and make our lives for our customers a little bit easier. Because on the 12th step, he had finally fixed the promise, reapplied that CR, and showed it all working again. And I thought, is this the experience we want for our customers? Is this really what we want to do when someone's trying to fix a problem with our K8s controller? And this is how it relates to Shrek a little bit, because how we find and interpret information is crucial. So Shrek had to find out a bunch of information, had to figure out how to interpret it. We were making that hard for our users. So let's recap Sid's pains and how we would address them. So interacting with the platform was really hard. Had to set up aliases, had to run those commands multiple times, had to try and figure out and interpret this information that was confusing across multiple different locations and pods. And then once you did find where you would needed to look, interpreting those logs was really hard because there was so much information in them, they were incredibly verbose and hard to understand. So how could we improve it? Because that demo showed me we really needed to. We needed to make this experience better. And that's when I handed it over to the engineers.
Great. So here's the pain we had. The first pain of Sid is interacting with the platform is hard. And what did we do to solve this? So we started thinking about, well, this might be an interface problem, right? We have kubectl, which is Queen, should always work. We'd expect people to do stuff with kubectl. If your product runs on top of Kubernetes, hopefully it works and you can get the information that you need with kubectl. But as the alias show, there is a lot of long commands that people have to remember. I bet that all of you have a Control-R kubectl-l, and then you kind of press Control-R multiple times to find that one command that you found once. But it should work. It's great. However, we can do a little bit better, and we can do a little bit better by doing everyone's favorite. Every product out there has a CLI, which is great, right? CLI is a thing that allows you to build a better experience. You go and you craft smaller commands, straightforward commands to make sure that people can get the information that they need the way, like in a simpler way. Tekton is a very good example of that. Tekton has, I don't know if you're familiar with Tekton, it's a workflow engine that runs on top of Kubernetes. But if you want to get your pipeline logs, if you want to get your pipeline history, you can do with kubectl, or you can do with a very short, very memorable Tekton command, CLI command, to get that information for you. However, that's another thing to learn, another thing to download, another thing to install, which some of our users may or may not want to do on day one. So what else can you do? The second favorite for everyone, GUIs, right? Graphical user interfaces are pretty good. And that's probably some of you in the audience right now. And trust me, I was there. This is when Kat told us that we should do a GUI. I was like, no, Like we are engineers. We like a terminal. We like our tmux, our NeoVims. We have kubectl, we have a CLI, we may have an API. What else do you need? But in fact, not everyone is as good as us. So yes, we found about Headlamp. Headlamp is a GUI system. It's like basically a React website. And trust me, I like React as much as the person sitting next to you. But it allows you to build actual graphical user interfaces on your Kubernetes cluster in a very, very simple and easy way. This is what it looks like. This is what we build. You may not know a lot about our product right now, and that's fine. But at a glance, you can see a system. It has colors, it has fonts, it has links you can click about and you can discover. And a graphical user interface actually makes that at-glance experience so much easier. Without knowing much about the product, you can see there's some things green, some things red, right? And that's allow you for a quick debug experience. You can easily see what is going right and what's going wrong. And the final thing that a GUI allows you to do is to click about. So you can see that in the promise page, we have some links. There is some things on the left, things on the right, things on the bottom. People are curious, people click about, click around, and discover and find out the information that they need themselves without you having to write a lot of docs. Because we also learned that our customers don't actually read the docs. I don't know if you discovered that, but this makes them, like the journey of self-discovery a little bit easier. So that was the first pain. It's like the information that I want is hard to find. Providing different interfaces may help people find the information that they need. The second pain that Sid had is that our logs are hard to understand. So before we jump into what we've done, let's think about why is it so hard to get the logins correct, get logins right. So this is the system. This is what happens when you install a promise. Don't worry too much about it. Each system will have their own resources like tree and stuff. But when you install a promise, basically, a lot of things happen in the system, right? So what happens if I add a log line in the promise controller that says, I'm here? Well, that one log line will show up every time that any of those resources change. Because of the ownership model, that promise will reconcile multiple times throughout its existence. So what does that mean for that log line? Basically, there will be loads of them. In fact, this is a quote. We had an escalation in our product. One of our customers complaining about it. There's a lot of text. I will highlight the important bit. Our controller was able to log 3,000 lines in about 2 minutes. Our customer sent us a message saying, hey, I think I broke something. And no, that was fine. Everything was completely fine. We just logged a lot of lines. So what can you do about it? Log less. Next pain. No, just kidding. This is like not quite great, right? Like let's be a little bit more helpful. So if you go into the code, this is a snippet of our controller code, and you can see there's a lot of log lines in there. What they are, less important, but you have like suspending job, checking status, a lot of pieces of information that are logged when the controller reconciles. So the first question that we asked ourselves is, who cares about those lines? Is it the operator? The person that is actually managing this platform? Is it the user that is interacting with the CRs? Is it the developers, people that are like building their stuff on top of Kubernetes and maybe extending our product? Or is me, the developer, that added like a I'm here sort of log line to make sure that I'm reaching the point of the code that I want? And the second question we ask is, what are those logs for? Are they to provide a heartbeat of the system? It's just like, I'm alive. So you know that the controller is reconciling, it's doing stuff. Is it to debug issue? So I have a problem, I want to figure out what's going on. Or is, again, for you to know that the code that you wrote is actually being executed. The sad truth is, the answer is yes for all of them. So logs are for all of those cases, right? You need logs for yourself, you need logs for your users, for your operators. So what can you do about it? Log levels. We got together in a room, we went through like what happens when the system reconciles, and then we try to understand like what happens when each one of those state changes, and who cares about the information that happens when like these things are happening in the system. And we came up with 5 log levels. Unsurprising, this is also in the industry standard. We have error, warning, info, debug, and trace, and each one of those log levels belong to, or like send a piece of information to one of those personas, like the operator, the developer, and the user. At the lowest level, we have us. So we have that log line that says, I'm doing this, I'm doing that. And then the highest level, we have just like, this thing broke. So the operator can do something about it. And allowing your user to configure those log levels, make it, then to be able to control how much log they want in the system. The second thing we did was think about reconciling less. So if adding a log line means that every time it reconciles, that log will be line will be logged, reconciling less will allow you to control how many times that shows up. So this is also, again, a snippet of code of K8s. What we did was to add a simple predicate. If you're familiar with KubeBuilder, if you use KubeBuilder, you can do that. You can actually control what will cause your controller to reconcile. So in this case, we have the work controller that owns a work placement object. We added a log line there that we only want to reconcile the work when the status change, a particular status change in my work placement. So if someone goes and just adds a label, I don't want this reconciliation to happen. So you can do that. There's a link over there in the bottom. I will find the slides later on as well that allow you to control how many times that controller reconcile or other conditions. Next thing we did was to add some structure. So our logs, our primary user of our logs were ourselves, but we can also have our users and we also have machines. So adding structure, just making sure that you have like a JSON or structured logging allows you to interact or interface that with other systems, other machines, make like that do sampling, that do like different sort of logic around it, which makes it so much easier for the users to know what they're looking for. And finally, this Kubernetes is an eventually consistent system. So not all errors, not all things that are wrong are actually wrong and need to be logged. So for example, conflicts, when you try to update an object and the object has been updated by another reconciliation loop, is that an error? Or is that just like, okay, let me try again later on? Like, do you need to log that line? So we applied all of those strategies and we were able to reduce our log lines by 67%. So do the math, 67% of 3,000, still a lot of log lines, but you're getting there and reducing the verbosity of it. And that's the end of chapter 2.
Okay, chapter 3, Victor's Grand Kubernetes expectations. So we're going forward a little bit in time now. It's January 2025. The team has had their Christmas party, New Year's party. We're all come back well rested, well fed, a little bit fat. And our head of marketing goes on Slack and shares a video in one of the channels. And this is the video released on December the 30th, so we are forgiven for missing it over the Christmas period. But it was the DevOps toolkit. So this is Victor Farsick, and he does reviews and shares information about different products. You've probably all seen it. And he was reviewing a tool called Crow. And Crow is kind of similar to how our product works in that it creates abstractions that encapsulate the Kubernetes resources. So ours does a little bit more than this, but he did this review. And as he was going through this review, his kind of feedback in general was the product wasn't particularly mature yet. They were missing some key things that he would expect, like how mature and integrated it was with the Kubernetes ecosystem and rules that are expected from Kubernetes tooling. Some of the docs wasn't as mature as it could be. So after watching this, my product manager hat went on of like, oh, okay, let's think a little bit about this experience. And if I hired Victor, if I had all the money in the world, I would be thinking, what would Victor Farsick do? What were the first things that he would be adding as tickets in our backlog? But really, we're never going to be able to hire him, like he's a busy man. So instead, what would happen if he reviewed our product on the same tooling? And he was going through the same way and putting it onto his YouTube channel. What would Victor Farsick expect? So then I reached out to the team and I said again, like, hey, can you have a look at this video? And then basically give me a list of all the things that we need to do to get mature so that if he did review our product, we wouldn't be in the same situation as Crow was, and that we'd be able to get, like, nip some of those more low-hanging fruit in the bud. So let's go back to our image that Derik showed earlier, and this is where we started with the areas that we needed to improve based on the kind of things that Victor was looking for. So there's a lot of things here, and like Derik said, this is a bit of a tree and it's a change. There is ownership model going on, but we don't expect or even want the users of the platform, those platform engineers, to know about all of these internals. They shouldn't have to. There should be a neat, easy experience for them to debug it. So what happens if this breaks? This is a work placement. It's pretty far down the stack. What happens if that breaks? There's a lot of things that a user needs to go through to find out that problem and to dig into it. And there could be multiple of each of these arrows. We're not talking just like a direct line here. These all fan out. So what is that platform engineer going to do, particularly if we don't want them to know about those internals? Because, like Shrek in his swamp, things are often good until they aren't. So you can happily have a platform that's running, performing all nicely and behaving as you expect, but until when something breaks, then it gets really complicated. So one of the first things that most Kubernetes users will do is a k-get describe. And when we look into kubectl describe on our product at the time, we realized that it was very quiet. We weren't making it very easy for you to find out what was going wrong if you were using that Kubernetes native tooling in the first place. So we had to ask ourselves, how can the user find that broken component if kubectl describe wasn't giving them that information that they needed? And the problem was, that single apply that happened could make many, many resources. And those all fan out, and they have connectivity between them, but the user doesn't understand the relationship. They don't know which thing spawned another thing, and which that thing spawned somewhere else, and how do I come back up the stack again? And what happens if one of those things fails? What happens if multiple of those things fail at the same time? You can get misdirected really, really easily. So how can you debug and fix the actual issue that you're trying to fix here? Chinyu got very excited about this. She thought it was a lovely little track of work, came up with a bunch of stories, so that this Vic guy, if he ever does talk about our product, we will probably get a load of different issues, but it won't be the ones that we found today. And Derik's going to show you what we did.
All right. Yeah, what we did to solve the problem. The data we need is hard to find. Think again, we started by asking the question, what is the right data to expose? Which brought us back to the personas that we talked about. Is for the operator, for us, for the developer, et cetera, et cetera. So we started thinking, like, who is the data for on that we are wanting to surface in our system? So we came up with 5 design principles. Basically, this is what you see in there. The first one is from any resource to its sub-resources. So we know that a promise creates a work creates a work placement, and so on and so on. So if any of the child resource breaks, we should be able to find from the parent resource the cause of issue. So it's basically you have a chain of events, a chain of status, and a chain of conditions that allows you to find that a component down the stack that broke. It also should be unsurprising for kubectl users. So we talked about kubectl get and describe. We should have some information there for the user to find something. They shouldn't need to go to the logs and grep and try to read that massive wall of information to be able to find what's going wrong. We should also have a clear state indicators for all the K8s resources. So is it good or is it not good? We should be able to see it very quickly what's going on. And with that, we also thought about consistent status fields. So we have maybe 8 CRDs. All of them should expose some sort of information, some sort of status and condition that is consistent across them. So the user doesn't have to think about it every time that they get to a new resource, what is the status of that thing. And finally, whenever a state changes, so if it was good, now it's bad, it was bad, now it's good, we should emit an event. So the user can track what happened over time, can put their dashboard, sell alerts, or whatever else that they need. And what does that mean in practice? Well, backlog of stories. Our backlog is public. You can actually go and search for the epic and see what we did. But in a big summary, we started with common labels. We did the ownership model, of course, but we also added labels so you can see from the child resource who owns it. So from the work placement, you should be able to have a label there that has the work name. So that's the association with the work. From the work, you should have a label that associates with the promise name. So when you want to search for things that belong to a promise, you're able to find everything that belongs to it with a single label selector. We also made use of the CRD's features like additional printer columns and validations, which allow you to customize what the user actually see when they run kubectl get. It took us longer than I'm proud of to do the very basic thing that is to show better information of it. But again, you don't need to know much about our system to know that everything is going well on the second screenshot because we actually have the status there showed up in the kubectl get list. We also did status and conditions. So we went through all of our resources and thinking about what are the conditions that the user care. And happily, there is a very big document. I'm pretty sure that most of you are familiar with this. Maybe some of you have actually read it. But it goes into details about what should your status and conditions be for your resources. So highly recommend to read. We went through it, and we added a lot of conditions and status of our resources, taking care to not have double negatives. I think that was from that document, one of the biggest takeaways is like, don't have double arguments, like failing, true, false. Is it failing, false, false, failing? What is it? So make sure that you have conditions and status that make sense. And finally, when those status change, we should now emit events. So when they use the kubectl describe, they don't have that quietness anymore. They're able to see when and how long and how often things change from one state to another. And yeah, we did all of that, and I'm happy that we now spending much less time. So implement destination status. Destination has a secret associated with it, and the number of times that we spend a lot of time debugging things, and it's just because someone base 64 return. Destination status is the best feature that we ever implemented. Shows that particular piece of data. And that's chapter 3.
So our final chapter is the observability onion. And I call it an onion because one thing you find with observability is you may not be solving the problems that you actually need to solve, because there is a lot of information that you're trying to consume here. And that's because it has layers. There are lots of different layers that you have to observability that you have to go through. And like an onion, ogres have layers too. So observability is like an ogre, I like to think. So let's talk about the basic level. So right at the bottom, you've got your logs. So these logs are the things that someone knows exactly about your system. They're really into the weeds. They can get all of the information. They should be able to find everything they need to find from the logs. However, how do I know when I need to check the logs? That's where status can come in. Is my resource red? Is it green? Is it healthy? Is it not? That's how you know to look into that thing and dig that level deeper into the logs. But how do I know I need to check the status without having a dashboard that has all of this information on it and constantly keeping an eye on it? Then you go into events. So these will fire off and tell me when I need to investigate something. And that's really, really helpful at that level. But there are lots more interesting parties, which is how you build it up into your metrics. So am I meeting my SLAs? Am I meeting my SLOs? How do I know that my system is behaving in adherence to all of these objectives and guidelines that I've been set? So you build up that next level. And then you keep going into traces. So what's the story over time? If I have missed that SLO, why is it? Something broke? What's the impact of that thing on the system? What happened before it? What happened after it? How do I make sure that that thing that I thought broke is the actual problem, and it has not happened further up or further down the stack, and I just haven't realized it because I've not got the right information at the right place? And these are all quite technical things that aren't the most easy for people to understand. So you can bring that the next level into your interfaces. So the interfaces are the ways that people would interact with it. Developers can love that kubectl view, but that's not going to be great for your business stakeholders who want to make sure that they're getting the ROI of their platform. And that's where your dashboards and your observability tooling in the GUI can become really, really powerful as well. So you've got to think about all of those levels for all of your different personas as well. So in summary, I'm going to show the screen. I'm not going to read it out because we're very low on time. But here are all the things that we did in our product to make it easier to observe kind of everything that was going wrong. And if you do at least some of these, you don't have to do them all. You too could ride off into the sunset in your beautiful onion and live happily ever after. So we also said there'd be AI in this talk, and we didn't. We ran out of time. But we asked AI to build this observability onion for us, and it didn't do a very good job. So maybe they need to improve their observability as well. So hit me up, OpenAI. I can help you. But that's it. That's us. Thank you very much. We are here all day. We've got a booth, so come find us if you've got anything you want to chat to us about or you want to hear more about how we built better observability. It's 1763. Thank you very much. We've got like a minute left if anyone's got a really quick question, but we'll hang around for a bit.